flow again, we finally reached slope-intercept form. And slope-intercept form is an equation in the form y equals mx plus b. That's not a 6, it's a b. Y equals mx plus b, where y stands for y and x stands for x. M represents the slope of a graph. And by slope I mean whether it goes up, down, vertical, horizontal. Although the last two cases, a little arbitrary. Up and down for the most part. And B represents something called the y-intercept, and I'll abbreviate the word intercept. So M stands for the slope and B stands for the y-intercept. I think we should just dive into the problem. We should just graph y equals 3x plus 4 right away. And that's what you're supposed to do when you do this problem. You're supposed to get y by itself. It's already by itself though. It's already by itself. And that's what you do when you do slope-intercept form. It's in the form y equals everything else. Let's do it. So when we're graphing this, there are a few problems that I've noticed that students have initially. Let's take care of it. Pay attention, rewind it again and again if you want to, just to make sure that you do it right. Here we go. The first thing that you plot is the y-intercept, which is this number. The number without the x is the y-intercept. That's after it's solved for y. So the number without the x is the y-intercept. Now when I say y-intercept, it means that it intercepts the y-axis. The y-axis is the one that goes up and down, or vertical. And it intercepts at 4. So that's what we're going to do. So we start at the origin and we count up 4. That's the first part to graphing in slope-intercept form. The next thing we do is we graph the slope. And the slope has a rise over a run. It means it goes up and down and then it goes side to side. Let me say that again. Up and down, side to side. That's like some kind of, Karate Kid thing, but whatever. And the slope is 3. It's rise over run. What a slope has to have is a numerator and a denominator. It has a numerator 3. If it doesn't have a denominator, the denominator is automatically 1. Let me say that again. If it does not have a denominator, the denominator of the slope is automatically 1. If this was a 2/3 x, you don't have to put down a 1. But since it's a whole number, then you have to put down a denominator. So the denominator is 1. So here's what we do. This top number stands for the rise. If it's positive, and by the way, your denominator is not going to be negative. It's only going to be positive. But your numerator can be negative or positive. It says 3. Your rise is 3. And you rise it from the y-intercept. So you start from the y-intercept. Once you plot the y-intercept, then you put in the slope. Your rise is 3, so you go up 3. 1, 2, 3. Don't plot. And your run is 1. And that's a positive number, so we're going to run 1. Congratulations, you just created a discrete function. We're going to make it continuous when you plot the points. That's all you do. We're going to finish that, but just give me a second. Let me say this again. You plot the y-intercept first. Starting from the origin, you go up 4. 1, 2, 3, 4. Then you work with the slope. Rise over run. It's 3, rise, run 1. 1, 2, 3, 1. Here's a fun, interesting fact. Besides going up 3 over 1, you can do the opposite and still keep the line. You can go up 3, right 1, or you can go the opposite, which is down 3, left 1, and it will still create the same line. It's just an interesting little fact that some people like. You don't have to stop there. You can continue going forever and ever and forever and ever, but 2 points is sufficient. Not a perfectly straight line, but I tried my best. And hopefully you will appreciate that. So it's a linear function. It goes up like this. I would look at this lesson again, especially if this is your first exposure to it. The domain goes all the way. So your domain is negative infinity to infinity, and your range is all the way south to all the way north. If this graph kept going over and over, you could keep going forever this way, this way, this way, and this way. Your domain is your x values, and your range is your y values. It'll keep going down, and it'll keep going up. With that said, go ahead and practice this. We're going to try a more challenging example. Make sure you got the hang of this one, especially if you're doing your homework. You can verify with a little bit of proof, but other than that, it's pretty copacetic. I'm going to do one more example like this, and then we're going to work on the relationship between graphs in y-intercept form. With that said, have a good day for now. Goodbye.